Alright, so I think I'm recording. Let's take a look at this problem. Scores on the test averaged 72%. The range of the scores was 50%. Write and solve an absolute value equation to represent the situation and find the highest and the lowest scores. Alright, so this time, let's draw a number line. Let me think about this. If, that's not a very good number line. In my absolute value, I want the center. It's more or less, I'm thinking of 72% as the origin, as the middle. Okay, so I'm just going to let my number line be percentages. If the range is 50%, then that means that this maximum value minus this minimum value is 50%. Okay, um, if the distance from here to here is 50%, and if this is representing my middle, then the distance from here to here is 25, and the distance from here to here is 25. Okay, so we're good. Now we're wanting to find these two numbers, and we're going to let x equal the 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 we'll let x be the true score. And see, x is taking on, the reason I'm pausing here and as I'm thinking, x is going to have two solutions. One where x is a maximum score, and this is a minimum score. So I guess I'm having a hard time. It's not that, I guess, true. It's the average score. No, it is. The average was 72, and most people scored that 72. But this is, so this, I can call this the true score. Okay, so I've got x minus 72 is equal to 25, which means that x minus 72 is negative 25, or the x minus 72 is equal to positive 25. This represents that you're 25 units below this average. So 72 minus 25, 47, and 72 plus 25. Well, you're almost at 100, yeah. Okay, so if it's true that we have a bunch of scores and their average was 72, and we looked at the highest score and the lowest score, and that range of values was 50, then we've just figured out that that maximum score had to be a 97 and the minimum score had to be a 47 in order for this to be true. You know, yeah, it has to be that. So these scores, these percentages are our answers, where this is the min and this is the max, and we're done. All right, so let's look at the next one. The average time it took for a group of students to finish a test was 37 minutes. The shortest and longest times were equally far away from the average. And yeah, that's okay. That makes sense, because the average is the middle value. The the longest time was 42 minutes. Write and solve an absolute value equation. So this is to find the shortest time. This is very similar to the last problem. So we have an average, and instead of percents, this is representing time in minutes, an average time. So if 37 is here in the middle, we have a minimum and a maximum, and we know that we're representing that these are equal distances away, so 37 is in the center. The longest was 42. Write and solve an absolute value equation to represent this situation and find the shortest time. All right, 42 minus 37 is 5. So an absolute value that represents this is let's let x be the average time, and I have the absolute value equation that 37 is my center. I'm within 5 units, so x minus 37 equals negative 5 is going to give me my minimum, and x minus 37 equals positive 5 is going to give me my maximum that I already knew. I already knew that I should get 42 here, but I didn't know until I set up the problem and started thinking about it that we would have a 32 here. So it wanted to write and solve an absolute value equation, so here's the absolute value equation, and then the shortest time is 32 minutes. So there's our two answers, the equation and 32 minutes. Let's go ahead and look at this next one because I'm running out of time. I'm going to have to take off here in a minute. And ideal vacation colleges equally spaced along a street are numbered consecutively beginning with 10. Maria lives in cottage 17, and Joshua lives 4 cottages away from Maria. What are the possible numbers of Joshua's college? So they're just the 10 here is a little bit extraneous because they're just telling me that there's enough cottages for us to really do this problem. So let's just use this as a map, and here's the cottage that Maria lives in. Okay, and we can call this cottage number 17, and we'll assume that they're numbered. Yeah, it says numbered consecutively, so they're numbered correctly. It's a count of how many there are, at least beginning with 10. So it's not, we don't have, I shouldn't draw arrows on we don't have infinitely many cottages. There is a fixed number of cottages. So our number line, we're just using part of it to help us with this. Joshua lives in a cottage also, the same as Maria. But we don't know if his cottage number is above or below Maria's. We do know that he lives within 4 cottages. So we do know that she's in the middle of these possibilities. So we can whittle it down to one of 2 numbers that has to be Josh's cottages. Either he lives here or he lives here. X minus 17 equals 4 yields us 2 equations. Negative 4 or x minus 17 is equal to positive 4. If we add 17 to each side here, and over here if we add 17, 21. So either Josh lives at cottage number 13, which is 4 units, say, to the left on the street, or maybe north or south. If this is south and this is north. South of Maria, 4 cottages is where Josh lives at cottage number 13, and north over here at cottage number 21, 4 cottages past Maria's is where Josh lives. So it's either one of those 2. So those are our 2 answers. Let's do the next one real quick as well. Martin makes exercise weights for his 10-pound dumbbells. He guarantees that the actual weight of his dumbbells is within 1/10 of a pound of the 10 pounds. Write and solve an inequality that describes the minimum and maximum weight of his 10-pound dumbbells. So his production process must not be, like NASA accurate, kind of like that thermometer of a problem earlier that although it's stated as 10 pounds, it might, it's not going to be exactly 10 pounds. Martin sometimes has weights that are overweighted or underweighted, but not by very much, by just 0.1, by 1/10 of a pound. So if we let x be the true weight, we know it's close to 10, but it's not going to be exactly 10. Its target is 10, but its tolerance, it's within 1/10 of a pound. So if x minus 10 is equal to negative 0.1, or x minus 10 is equal to positive 0.1, x is equal to 9.9 pounds, or x is equal to 10.1 pounds. So those are our two answers. You know that 9.9 and 10.1 are 1/10 of a pound away from that target, that stated the center value, the ideal value, the origin, what we wanted to originate from. All right, so hey, I hope that helps, and I'll talk to you later.